let's go ahead and go through both versions of the quiz from September the 4th. And regardless of which version of the quiz you have, they both had the exact same first two questions. So here we go. The inverse of this is not simply that, but it is this with this restriction. Why is that? Well, first of all, I accidentally left something out. That actually should say F inverse. So the inverse of that is not just this. If you switched X and Y and solved for Y, you'd get this. And real quick, I just want to show you that just because. X equals square root of Y minus 2. We'd get rid of the square root first. We'd have X squared equals Y minus 2. Then we would add 2, so we have X squared plus 2, and that is now our inverse. And that looks like it's it, and it looks like it's correct. But again, it's not. It's not just this, but it is this with a restriction. The question, of course, is why. Well, first of all, the original graph looks like this. And it passed the horizontal line test, and we'll talk about that in a minute. But the inverse that we have here looks like this. Let me get a pencil and I'll show you. It looks like this. So why do I have to place that restriction on it? There's multiple answers, and I'm just going to give you the quick one. The range of the original, and I'll write this down. The range of the original function must correspond to the domain of the inverse. And I know that sounds like a lot of mumbo jumbo, but I'm going to clarify it one more time. I remember when we were doing the lesson, and I hope you remember this too, that any coordinate has the reverse on there. For example, if this coordinate, some a comma b, is on the original, then there's a corresponding b comma a over here. Well, then where'd that one come from? And that's the whole point. So we have all these points, that these actual coordinates that had the reverse on the inverse, so we didn't need all that. It was extra. Some of y'all wrote things like it had an extra leg or extra appendage, and that's the way I had explained it in class. Nevertheless, ultimately, this is the most correct answer. Okay, why doesn't this one have an inverse? And I had a really clever answer on here, and it said because it's hard to solve for y if you were to switch. Don't write this down. But if you were to switch x and y, it would be difficult to solve for y when it's to the fourth and cubed, and that was actually really clever. And that is sort of one of the reasons. I don't think I counted that one wrong. Nevertheless, here's the real answer. The graph of it, I don't remember exactly, but I do know that it fails the horizontal line test. And I want to explain why failing the horizontal line test gives a death blow to a function. There it goes. It does like that. So it goes down and it comes up about like this right here. I don't know why I had to graph that. I should be able to do that in my head, and I sort of did now that I see it. Nevertheless, here's the thing. It goes back to what we said about reversing coordinates. If I have some coordinate here and I reverse it, then I'll plot it and it'll be about here, I guess. And if I have some coordinate here, then I'll plot it and it'll be about here, I guess. Well, by the time I do that, I've got some little thing going on here that doesn't pass the vertical line test. So if I was to take this little thing and find its inverse, it's going to kind of flip it around like this, and instead of it looking, it's not a parabola, but instead of it looking parabola-ish, it would be a sideways parabola-ish kind of thing, which means that in my inverse, this is a really rough sketch of what my inverse would look like if it did exist, it wouldn't be a function. So it doesn't have an inverse function at all, because the original fails, I'll do it in red, the original fails the horizontal line test. See, I've hit 2 points here, meaning that when I turn this thing around and get an inverse, it's going to fail the vertical line test. So let me write that down. It fails the horizontal line test. Okay. At this point, you might need to figure out which version of the quiz you have. Take a look at this one. If you have this one, then keep following along. Otherwise, you can skip forward in the video to the other one. So here we go. We are going to, first of all, make sure that it passes the horizontal line test. You know what a line looks like. It looks like that right there. Sure enough, it does pass the horizontal line test. I can pass a horizontal line through here. It only hits at one point at any given point. So x equals 4y plus 12. We will solve for y. First thing we will do is subtract 12. And then we have 4y. And then we're going to divide by 4. And some of you, bless your heart, you didn't divide everything by 4. This is acceptable. This is also acceptable. We'll divide the first term by 4 and the second term by 4. Either one of these is correct. That is the inverse right there. There we go. Either one of those is good. The second one, when we graph this, it does this little thing. It kind of goes like that. And sure enough, it passes the horizontal line test. It does. It never touches at more than one point if I pass a horizontal line through it at any given point. So therefore, we'll switch x and y. Fifth root of 5 plus 5y. A lot of 5's in here. How do we undo a fifth root? Well, we raise it to the fifth power. We will now subtract that 5, x to the fifth minus 5 equals 5y. And then we'll divide by 5, giving us x to the fifth minus 5 over 5. I'm kind of skipping a step. I hope you're okay with that. There's our inverse. This is the answer. Some of you wrote it like this. I should come over here and do it. Some of y'all went x to the fifth minus 5 all over 5. It's the same thing. These are the same. This one is a more simplified version of that. Okay, next one. The graph of this one does not pass the horizontal line test. There we go. It looks like that. If I pass a horizontal line through here, it touches at more than one point. Meaning, if I was to find the inverse, it would do something like this and would fail the vertical line test, and it would not be a function at all. So, no inverse. If you want to be a little more accurate, I probably should say no inverse function exists, but I think you get the point. Okay, let's switch x and y here. Oh, by the way, I'm switching x and y because it passes. Some of y'all thought that it fails right here. I'd mentioned this in class. It does not fail. It looks flat there. It is not flat. Technically, it is flat for one point, but at that one point, it still doesn't fail the horizontal line test because it's just 1 point. I know what I said was wordy, but this one passes. Trust me. Any horizontal line you pass through, even right there at the origin, it passes through at only 1 point. So it does pass. Deceptive looking, but it does pass. Okay, so we will undo a cube by taking the cube root. Equals y plus 2. Some of y'all did this in the wrong order. Cube root of x minus 2, and that's equal to y. I probably should have written that as the inverse. We'll do it that way. There we go. There's that answer. Okay, we're going to flip this thing over and get to the piecewise functions. Piecewise function, piece. I'm going to go through this part kind of fast. I'm going to go ahead and jump straight to doing it in pen instead of doing all the erasing and stuff with the pencil that I had been doing. Okay, here, looking for my ruler. There we go. What we're going to do is graph it and state the points of discontinuity, and you'll see what I mean by that in a minute, but we're going to graph the line y equals negative 2. So the line y equals negative 2 would be down here. But I don't want to graph the whole thing. I only want to graph the stuff that is less than or equal to 3, and that would be here. So, okay, I said the line was there, but I only want the stuff less than or equal to 3, so it's going to be this piece right over here. I'm going to go ahead and draw it in red. Hope I don't mess up because I am using an ink pen. We'll put a circle there, and because it is equal, we'll fill that circle in. Okay. Let's go to the next one. We'll go down to negative 4. It's a horizontal line at negative 4. It's going to start where x equals negative 3, and it's going to continue all the way to positive 3. So it's that horizontal line right there. Some of y'all, when you graphed it, you graphed some crazy stuff with some slopes that were like crazy diagonal. No. Don't do that. Negative 2, flat line at negative 2. Negative 4, flat line at negative 4. There are no x's in here. All right. The next one is at positive 4. 1, 2, 3, 4. And to the right. And I knew to start it there because that was greater than or equal to 3. I'll fill that circle in a second. 1, 2, 3. There it is. Okay. Discontinuities. A discontinuity is where it is broken. It is broken. If I was going to graph this thing, I'd have to lift my pen at negative 3. So I have a discontinuity at x equals negative 3. See if I have to lift my pen again. Oh, I do. And because I do, there's another discontinuity and it happened at positive 3. Okay, this is the one that ran off the graph, but that's okay. I actually am going to erase a little bit on this one. We will start at positive 4. 1, 2, 3, 4. There it is. Our slope is negative 3/2, so we'll go down 3 and over to the right 2. I had to answer a lot of questions with this in class, but basically, how do I know which way the slope goes? Here it is. That slope is negative, it will tilt downward. If the slope is positive, it will tilt upward. Now, it might be different slopes itself, but this one is downward. Here we go. So I'll draw that line and I draw that. Actually, I'm not going to draw too much because I know I need to stop it where x is less than or equal to 2. So right here it stops. And this is my actual line. Some of y'all actually went you did the wrong numbers with it. Some of y'all went down 2 and over 3 instead of down 3 and over 2. Be careful with that. Okay, let's do the next piece. Oh, I need to fill that in. Better fill that in. The next piece goes up to 4. 1, 2, 3, 4. Same starting point. We're going to go up 3 and over 2. I gotta draw a little more. Wow, it looks terrible. 1, 2, 3, and over 2. So there it is. And we'll connect those points. We'll draw our line. There it is. Oh no, drew too much. You know where I'm going with this. We only want to keep the part that is greater than 2. That's here. And over. So from here and over, we keep it. It runs off the graph. I don't need any of this. And that circle is not filled in. The video had cut off there. I'd run out of memory on my iPad, but basically what had happened was I was talking about where the discontinuity is. The discontinuity is at 2 because I would have to lift my pen. If I'm drawing this thing, I'd go zoop, and then I'd lift it to draw the rest of it, and I would lift it where x equals 2. So that's where that comes from. Okay, let's hit some of these word problems down here. You need a job. You decide to sell insurance, and the amount that you get paid depends on the number of policies that you sell each month. Based on that, and I haven't really addressed this that much in class, but I'm going to go ahead and define what x is. X is, I'll use an ink pen that works. X is the number of policies, that is not hashtag, policies I sell in a month. Or you sell in a month. You're the one selling insurance, not me. You're the one that needs a job. I have one. When you sell 15 or less policies, stop right there. Is it equal? Yes. Bless your heart, some of y'all had it written all kinds of crazy ways. The number of policies I sell is less than 15 or equal to it. I make $220 per policy. I know this is wrong. Go ahead and copy it, but this is what I do when this happens. Now, here's what's wrong about it. Some of y'all left it this way. It's $220 per policy. $220 for every X that I have. That's why I multiply them. Okay, we're at the end of that sentence. Next sentence, when I sell more than 15 policies, okay, I'm going to sell more than 15 but not equal to 15. You make $3,300. Sounds good. Plus $200 for every policy that I sell above 15. So we've been through this. I can't just put an X there. If I want to know how far I am above 15, I will subtract 15. There we go. This is our function. You can put f of x if you like. That's up to you. When I was counting these wrong or right, I counted this part, and that part holistically. This was all one big piece. By the way, just want to say this too. This, and discontinuities counted as 4 separate pieces. This, and the discontinuity counted as 3 separate pieces. Just in case you're wondering what my grading system was on this. How much will you make when you sell 21 policies? Some of y'all got this part wrong and this part right. So, I mean, you can kind of reason your way through it, but still we have to write the function. 21 policies is not less than 15. Of course, it's greater than 15. So we do 3,300 plus 200 times 21 minus 15. I'm going to go ahead and put a 6 there. So that is 1,200 plus plus 3,300. I'm doing this one in my head. I hope you're not offended. Well, sort of in my head. $4,500. That's a pretty good month. There we go. That's before taxes, though. How much do you make when you sell 2 policies? 2 policies, well, 2 policies would fall in this category, and 220 times X, that is $440. There we go. That brings us to the end of the first version of the quiz. The second version of the quiz was almost identical, just with different numbers and slightly rearranged, just to keep people's eyes from wandering, and yeah, here we go. The second one, again, first 2 problems, exact same. We're going to skip it. We've already talked about it. For this one, let's do the horizontal line test. Horizontal line test looks like that right there. Now, some people got stumped on that, and they didn't know if it was completely horizontal. Does it pass or not? We mentioned this type of problem in class. I'm stuttering. Sorry. It does pass the horizontal line test. Even at that moment, at that point right there, it does pass. It never touches more than once. No matter how far in you zoom, it'll only touch once. So let's swap them. There we go. We will get rid of the cube by cube rooting. Some of y'all did this in the wrong order. We will now add 4, cube root of x, plus 4, and that is equal to our inverse. There we go. And put this other one underneath it. So I'm going to cushion it a little bit. There we go. All right, next one. There it is. That's what it looks like. Does that pass the horizontal line test? Absolutely not. Get it? Absolutely not. It fails the horizontal line test, and here's why. It touches more than once, and here's why that's important. If I was to graph its inverse function, then it would end up looking like that, and it would fail the vertical line test, and therefore would not be a function. So, no inverse. You can leave it like that, but let's be technical. No inverse function exists. Okay, next one. This one is a line that looks like that. That sure enough passes the horizontal line test. So x equals 3y minus 9. We will add 9. And now we will divide by 3. And this is our answer. I'm okay with that, and you're okay with that. But we can also do this. X over 3, or 1/3 x, plus 3. Both of these are equal to the inverse. Any of those answers is correct. Okay, this one right here has an inverse function that looks like that. It sure enough passes a horizontal line test, so let's keep going with it. 4 plus 4y, and we will undo a cube root by cubing it. A lot of 4's in this one. We'll subtract 4, so x cubed minus 4 is equal to 4y, and then we will divide by 4. So x cubed minus 4 divided by 4, and that's equal to y. Okay, so there we go. We have it. However, let me write it again. We can make it x cubed over 4 minus 1, and that is our inverse function. So similarly to the way we simplified this one. There we go. Each one of these counted as one separate problem, and each separate problem I think was about 5 points, 5.5 points, something along those lines. Okay, let's flip this thing over and talk about piecewise functions. This one was funky, unintentionally funky. I meant to have these both be the same, either both positive 3 or negative 3, but it wasn't, so we just kind of went with it. So here goes. We start at 1. According to Lincoln Park, it starts with 1. We will rise to, it was a joke. Starts with 1. Anyway, we'll rise 2 and run 3. There we go. How do we know which way it tilts? It's a positive slope, therefore it will tilt upward. So we will go positive 2, positive 3. Here's our line. There it is. And that is a lovely line that you can probably barely see on your screen, but that's okay because we only want to keep the part that is less than or equal to negative 3. So from there, let's switch to red, from there and back, we will keep it. And when I say from there and back, I mean there, like fill that thing in. There we go. The next part, we'll start at 3. So 1, 2, 3. Slope is -2, so I mean we can go down 2 and then to the right 3. If you wanted to, you could go up 2 and back 3. Either way, they fall on the same line. And there is our line right there. And we only want to keep the parts that are greater than 3. This was a very odd piecewise function because it truly was broken with a huge gap in the middle, which raises all types of discontinuity questions, like is there a discontinuity, is there not? I didn't get too picky about the discontinuities on this one. You can say that there's a disco at x equals -3 and 3. You could say that all this is discontinuous. We can get real technical. I didn't get really picky about the way you wrote this answer right here. If this graph was right and you had one of those, or you said something about a discontinuity, you were good. Okay, that was one part, that was one part, that was one part. Each part I think was worth about 5 points. 5.5 or something. Okay, here we go. Next one. Next 1, not 1x. If it was 1x, it would tilt upward. It's not 1x, it's 1. And it is 1 horizontal line from -3 and to the left. There it is. Okay? -2. Boom. Only exists from -3 to 3. -3. Right there. See? Down 3. And it only exists where x is 3 and over, including it. There we go. We have 2 discontinuities. A discontinuity, if I could spell it, the discos, that would be where you would have to lift your pen to keep drawing it, or if you're driving a truck across it, where you'd fall off, where there's gaps. Technically, you call them, in the calculus book you'll see next year, it calls them gaps, holes, and jumps. But for now, we can just oversimplify things and say that you're jumping, or there's gaps. Okay, so you fall there, and that's at -3 and at +3. So -3 and +3. It's where x is -3 and +3. Same answer as the last one. Okay, next problem. Piecewise function. You need a job. Man, you need a job. You gotta pay for a lot of stuff. You decide to sell dog houses. There's not much of a demand for that. Good luck with that one. And the amount that you get paid depends on the number of dog houses you sell each month. So this is what I've done with the other version of the quiz. We're going to just go ahead and define what x is, just so we won't lose track of it. X is the number of dog houses. Hashtag dog houses. I sell each month. Okay, write the piecewise function that represents this situation. Well, let's keep reading. When you sell 10 or less dog houses. Cool. When I sell 10 or less, I have sold less than or equal to 10. That wasn't so hard. Wasn't so bad at all. Now, this is the constraint, and there's going to be something that goes with it. So when this condition is met, then I do a certain thing, and that certain thing is I make $40 per dog house. So $40 for every dog house. So 40x. Okay. When I sell more than 10 dog houses, well, that's pretty straightforward, more than 10, I make $440, plus I also make $35 for every dog house that I sell above 10. So it's not going to be 35x, but it is going to be 35 and then x minus 10. And the reason that is because that will help me determine how far above 10 I am. So if I have 11 dog houses, I'm really going to get $35 for one dog house because I'm only 1 over the 10. So we subtract it. Okay, how much do you make when you sell 21? 21. That goes here. 21 is obviously greater than 10, so we're going to plug it in there. So we have 440 plus 35, and then 21 minus 10, so we're 11 dog houses over. And I'm trying to do that in my head, and it's just not working right now, so 35 times 6, 11, I'm sorry. If you're wondering where I got 6 from, that was the number that popped up here in the other version of the quiz. Just in case you're wondering why I can't subtract 21 and 10. I have $825. Not really, but there we go. Okay, how much do I make when I sell 2 dog houses? Well, this isn't that hard. Some of y'all missed this one, and I'm not quite sure what happened. Some of y'all put 40, some of y'all put 20. I'm not sure where it came from, but 2 dog houses. 2's less than 10. 40 times 2, so 40 times 2, I make $80. There we go.